a few ways that it's different than Plastisol ink. It traditionally has a softer hand because it has a higher absorption rate into the garment, right? A traditional water-based ink absorbs all the way into the garment. And when you cure this ink, you're basically evaporating the water out of the ink, right? It's not like Plastisol where it has a melting point. And you're melting it on there, and bada bing, you're good to go. It has a more fuzzy kind of gray area cure time. The analogy I like to use for this is if you have like a real hot frying pan in your kitchen and you spritz some water on it, the water bounces around, right? And eventually it dissolves. But how long does that take? The answer to that is it depends, right? It depends on how hot it is, how much water there is, and it's the same thing with your water-based ink. You're trying to force evaporation of the moisture out of the ink, leaving the pigment behind. And again, it absorbs into the garment, so you're actually dyeing the textile a little bit more. The rule of thumb for curing water-based ink is it needs to linger. It needs to linger a little bit lower temp is okay, maybe 300 to 320 degrees, but it really needs to be there for about 90 seconds. The longer that it could stay there, the better, right? If you can keep it hovering at that temperature for 2 minutes, why you would choose to use a water-based ink over a Plastisol ink, one is the hand, right? It's absorbing into the garment, so it has a softer hand to it. The newer inks that have come into the market, say in the last like 8 years or so, called the high solid acrylic, or HSA, water-based inks, do not have as great of a hand as like your traditional ink that you're going to get at Blick or something like that, right? Because it's high solid acrylic. So you're going to feel that on the shirt. But it does act a lot more like Plastisol in the opacity sense, where it'll stand up on the shirt and kind of hold its own. You can underbase it with the white ink. You can use it on darker garments. Water-based ink, it does dry in the screen. And as you modulate the ink while you're printing, and as you're moving it around, it does start to evaporate, and it becomes like thicker and kind of chalky, and it will dry in your image. The other really fun thing about using water-based ink is emulsion. If you remember from earlier, emulsion is water soluble. Yay, and we need it to be water soluble, right? We take advantage of that to make our stencils. But water-based ink starts to slowly degrade the emulsion on your screen almost as soon as you put it down. So that's another reason why you really gotta go, right? You gotta start printing quickly and efficiently. You don't want to like start printing and be like, you know what, I'm hungry, I'm gonna go to lunch. No, that's an inefficient way to work anyway. But with water-based screen, you're going to come back and have a problem, right? Discharge ink is water-based ink that has a chemical reaction in the natural fibers of your shirt and dyes them. So if I just take a plain, it's a base, and we put pigments in it, and that's how we use this ink, right? So if we take a discharge base and we put our chemical activator in it, and then we print with that, it's gonna take the dye out of the shirt. So it returns the shirt really to the color of cotton, to undyed cotton, which is kind of like a light natural color. Now if I take that discharge ink and I pigment it to whatever color I want, right? And then I activate it with the chemical activator and I print it on the garment, it's gonna take the natural fibers of the garment, take the color out of it, and replace it with the pigment I put in the ink. What this does is it creates bright colors on a dark shirt with zero hand. Because we're changing the garment, right? We're dyeing the actual textile. Only works on cotton, hemp, and bamboo. That doesn't mean that like if you print it on like polyester, you get struck by lightning or anything like that. It just means that it's not going to affect the polyester. So that's just something to slip in the back of your mind, right? There are limitations to this process, but you can bend the rules. They're all just tools in your toolbox that you are pulling out to create something cool and unique and hopefully what your customer wants. So it cures much like water-based, 60 to 90 minutes, longer the better, truly. 320 to 330 degrees, same concept of trying to evaporate all the water out of the ink just to leave the pigment behind. Once you activate it, it stops working probably after I think like 6 to 8 hours. You can like reactivate it, meaning you can come in the next day and put some more activator in it. But if you're trying to reach a specific color, I do not recommend doing that, because the amount of activator that's in there, it's going to slightly change the color. Discharge ink is particularly volatile to emulsion. So if you're planning on printing with water-based and discharge, and again, this starts at the computer, right? This starts when you're looking at your image and you're deciding how you want it to feel. What colors are you going to look? Do you need to hit a specific color? Is color really important to your client? And they don't want just any yellow, they want their yellow, or they don't want the shirts at all. If that's what you're dealing with, I would not do discharge, right? Because it's a chemical reaction, and we can't control what happens to the garment before it reaches us. So, and that's a huge variable there for color. So you're going to start asking yourself some of these qualifying questions. If you decide that you're going to print discharge or water-based, then you need to prep your screens differently, right? Because emulsion is what? Water soluble. You need to take care of your stencil before you put it on press and slap this ink onto it. You need to make it stronger so that you can print with it. So what we do here is we actually burn the screen as normal, and then we'll go back and we'll take just regular emulsion again, and we'll kind of sponge it across all of the emulsion around the image, and then we'll put it back under the light, right? And just really bake it, really blast light at it for at least 3 times the amount of exposure time, right? So that we're really giving it a nice hard stencil. And then there's a product called hardener, and it's just a clear liquid. You can just sponge it on both sides of it, and it'll really help it stand up against water-based ink. Normally with Plastisol, as you saw maybe on the screens earlier, we tape them, right? And then there's the registration marks that Justin showed you earlier. We just tape over them, and then we're good to go. It doesn't quite work that way in water-based ink, because those registration marks, that ink will find it, yeah, and start kind of working its way into the stencil there, and then it kills the adhesive on your tape, right, and just starts squeezing out in these nice long tape lines. And once it's on the garment, you're done for, right? So we need to make sure that that's not going to happen. We need to prevent that from happening. If you're working on an automatic press, even just on the manual press, 2 lines of tape, whoop, very vertically right down the back of the screen, just where your squeegee is going to beat up that stencil, because we're going to print on it over and over and over again, and it helps. It helps keep the emulsion where it's supposed to be.